Okay, so now we are on question 5, which is your principle of conservation of linear momentum. So it says a truck of mass 1,500 kg traveling at a constant speed of 20 meters per second to the west. Note the direction there, it's west, right? So we know that whenever we are given our direction as west, we must take it as negative, right? Because west is to the left. Then along a straight horizontal road, collides with a stationary car of mass 900 kg, right? And the two vehicles move together. Note this. And the two vehicles moved together after the collision. So now this is telling you that you must apply case number 2, right? So if you are confused about what I'm talking about, you can check out my video that I'm going to share a description on the link for on momentum and impulse. So it's a full lesson video on the cases that you have to apply in order to calculate your principle of conservation of linear momentum questions. Okay, the collision lasted for 0.2 seconds, so that's your contact time. Ignore the effect of air friction. Then 5.2 says, explain what is meant by the term isolated system. Now for 5.1, what is an isolated system? We say this is the system, a system for which the net external forces are equal to 0, or for which the net external forces is equal to 0. Right, so system for which the net external force is equal to 0. Let's just say net external force is equal to 0. Yes. So a system for which the net external force F net is equal to 0. Then 5.2, state the principle of conservation of linear momentum in weights, right? So you are just given 4 marks in definitions there. That's just 4 free marks, right? Then what is principle of conservation of linear momentum? We are going to say it states that in an isolated system, the total linear momentum is conserved. The total linear momentum is conserved. Or others might say the total linear momentum in an isolated system is conserved, or remains the same, or remains constant. Right, so that's basically that. States that in an isolated system, the total linear momentum is conserved. Now, just like that, you have your 4 marks in the bag. Yeah. Then 5.3 says, calculate the speed of the vehicles after the collision. The speed of the vehicles after the collision. Now, this is where we have to apply our cases now. Remember, they said these two objects were moving separately. Then after collision, they did what? They collided and then moved it together as a unit. So they were coupled together.
It's about to go down.
Then this is sum of momentum initially is equal to sum of momentum finally, which will then become what? M1 V1 plus M2 V2. But then check this one out. As soon as they're now coupled together, you need to then consider that they will have the same final velocity, right? So if they're moving together as a couple, they should have the same velocity, right? Finally. So, okay, this is what we're going to do now. Our mass 1 is what? 900 kg. And then what are they saying about this 900 kg? A truck of mass 1,005 kg was the one that was moving at a constant speed of 20 meters to the west. Along a straight horizontal road, collides with a stationary car. Collides with a what? Stationary car. So car was stationary, and then this is 1,500, but then it was going 20 meters to the west, so negative 20. So here I'm going to indicate that I'm taking east as positive. Now for one that took west as positive, obviously your your velocity here is positive if you took west as positive. But then I just prefer to just take west as negative and east as positive because it's easier to remember that way. Then this is 900 plus 1,500. And then here we have VF, right? Which is what we are looking for. Now, obviously, your machine weighbalo there, we have to calculate. So we are going to say this is 1,500 multiplied by negative 20, which is negative 30,000, right? And then when we add these ones together, we have 900 plus 1,005. That's going to give us 2,400 and then final velocity. Then divide both sides by 2,400. 2,400. Then our final velocity will be what? Let's check. 30,000 divided by 2004. So that's going to give us negative 12.5 meters per second. Now, obviously, we understand the negative is indicating the direction. So therefore, we'll say, because we are looking for the speed, we are just going to say it's 12.5 meters per second. Note that we are looking for the speed, so there's no need for us to say west because the speed is just a scalar and no direction, right? So, okay, 12.5 meters per second. That's the speed of the vehicles after the collision. So that's the speed of the whole system of the vehicle and the car now. I mean, the truck and the car. So both of them are vehicles. Then net force exerted by the truck on the car. Now with this one, it's up to you. You can either calculate based on what is being experienced by the truck or what is being experienced by the car. But then in cases like this, net force exerted by the truck on the car, right? They say on the car, this is based on what the car is experiencing. So it simply means it would be best to just calculate using the one that is experiencing the force, right? So it's the car that is experiencing the force from the truck. We know that, again, applying your Newton's third law, the same force that the truck is exerting on the car is the same force that the car exerts back on the truck, right? So, okay, so we are going to say F net is equals to a change in P. So if you prefer to just write the original formula as it is first, can do that. And then this is based on the car. So on the car, we are looking for the net force, but then we are told that the contact time, the collision lasted for 0.2 seconds. So we put 0.2 here. Then we have our mass, breaking it down. This is M, V finally minus V initial. So that's how change in momentum breaks down. So this gives us F net is equals to 0.2. The mass of the car is 9 kg, and then the final velocity of the car is what? Remember, final velocity for both the truck and the car will be the same because now they're moving as a system. So this velocity that we calculated here now applies for both the car and the truck, meaning our final velocity negative. So this is where the direction is important. 12.5 minus initial velocity is what? 0, because initially it was just stationary. Then we are going to have F net and then 0.2. We can punch all of this into our umshinwe ibalo.
What are you saying? What are you saying? What is he saying?
So that's a, let's see, calculator. So this is going to give us 900 multiplied by negative 12.5, which is going to give us negative 11,250. Then we can divide both sides by this 0.2. Then our net force will be equal to what? So that answer there divided by 0.2. So this is going to give us negative 56,250. Right. Again, we are just calculating the net force. So net force is, remember the net force is a vector, guys. It has both magnitude and direction. So this is supposed to be 56,600 and okay, 56,250. Wait, 56,250 newtons to which direction? West, because of the negative there. So make sure that you indicate even the direction, because net force is a vector quantity. Okay, so that's how you would tackle your 5.3.2 right there.
I'm saying, and I say this without any fear of contradiction, we are cruising nicely.
So then, okay, 5.4 is saying now, is the collision elastic or inelastic? Use relevant calculations to explain your answer. Use relevant calculations to explain your answer. Then let's see now. For 5.4, the calculation that we are supposed to perform there is the one that goes EK initially, and then we calculate our EK initially, then also calculate our EK final. Now, the idea here is that if the sum of EK initially will be equal to the sum of EK finally, then we will conclude and say this collision is what? Is elastic. But if we find that the sum of EK initially is not equal to the sum of EK final, which is what you will find almost about 99.9% of the time, you will find that when you calculate there, it's just going to prove that it's an inelastic collision, right? So yes, I'm not saying you should memorize that, but then in most of the questions that I've already done, past exam papers, I've never seen a question whereby I calculated and then it was elastic. Maybe I'm about to still find that question, but then as of yet, all the questions that I've done always prove to be inelastic collision.
I can see what they're doing, what he's doing. I can see it, I feel it. He's cooking.
Right. So let's begin now. We have a half m. So do not confuse this formula with the one for momentum. This is kinetic energy, and it's supposed to be mvi square plus half mvi square. So this is for the car, and this is for the truck. So this is half 900, but the initial velocity for the car was 0. And then this is half 1,500. Initial velocity for this one was -20. Then you need to square that, right? Then obviously you need to punch all of that into your calculator. So this here will give you 0, right? So if you just quickly punch that into your calculator, it's going to be what? 300,000 joules, right? And then let's now see. We want to then calculate sum of EK finally. So this is equals to what? Half mvf squared plus half mvf squared. Now car, truck, this is half 900, and then final velocity. Remember, the final velocity we said is the one that will be shared amongst the two, because now they're moving together as a unit. So it's that -12,5. And then also here, this is half 1,500. And then we still have that -12,5. So, okay, let me write with a visible one, 12,5, and then square that. Okay, so now, obviously, you want to punch all of that into your calculator. You want to punch all of that into your calculator. So which will give you what? 187,500 joules. Now we can see that there's a significant decrease in the kinetic energy from the kinetic energy initially to the kinetic energy finally. So which is telling you that the collision is what? Inelastic. Because now that means some of the kinetic energy has been converted to other forms of energy during the collision and after the collision. So that means here we can then say, therefore, collision is what? The collision is inelastic. The collision is inelastic. Why? Because the sum of EK initially is not equal to the sum of EK finally. So that's the conclusion right there. So you are just supposed to prove using calculation whether this will be inelastic or whether this will be elastic or inelastic, meant to say. Okay, so that's basically that, guys. That's how you were supposed to calculate that. So nice. 5 marks. This is usually just 3 marks. This is 1 5 mark that is just for free in an exam. If you can just do this, then you know you have that 5 marks in the bag.
Oh my God!
Then, okay, 5.5 says delicate equipment is usually packaged using bubble wrap for safety of the equipment. Explain how this process keeps the equipment safe. Right. So here you are supposed to say the bubble wrap provides a soft surface for the delicate equipment. So delicate equipment are those equipment that maybe might break if you don't usually make sure that they are packaged very well, right? Like your glasses, your mirrors, and all this other fragile material that you might buy. The bubble wrap provides a soft surface for the delicate equipment, which increases what? Which increases the contact time. The contact time of collusion, right? Which increases the contact time of collusion. And then in a way, it does what? It then and decreases the net force that acts on the delicate equipment. That acts on the delicate equipment. So that's basically that. So all this explanation, so that's your point 1, point 2, and then point 3. All this explanation, guys, is just based on this formula here. F net delta T is equals to change in P. If you just divide both sides by delta T, and then you end up with F net is equals to delta P over delta T. For the same momentum, for a constant change in P, for a constant momentum, change in momentum, constant change in momentum, then we are looking at the relationship between net force and delta T. So we are saying if we can increase the contact time of the collusion, then we can decrease the net force that is being exerted on an object. And then by decreasing the net force, we are actually decreasing the impact or the impact of the collusion, right? So we are actually decreasing the impact of the collusion, the net force that will act on it. So this is just based on the relationship, the fact that F net is inversely proportional to the delta time for a constant change in momentum. So if we keep the change in momentum the same, because we are not changing the mass, we are not changing the velocities of this object, we are just simply increasing the contact time so that the net force will decrease. So that's basically that. So that's how you explain that for 3 marks. 3 points, the bubble wrap provides a soft surface for the delicate equipment, which increases the contact time of collusion and then decreases the net force that acts on the delicate equipment, making sure that the delicate equipment is packaged safely and then does not get to be broken, right? So, okay, that's definitely that. And then your momentum and impulse was for 20 marks, which again, we can agree this was the longest momentum and impulse question, and then with a very, very substantial amount of marks. So if you get into an exam and then you have 20 marks like this for this topic, I mean, it's a win. it's a win, because there's nothing that difficult when it comes to momentum and impulse. As long as you now know about the cases of collusion, of which go check out that video there. Very, very hot sauce things there. Hot sauce things there. You don't want to go to the exam without watching that video. Trust me.